Welcome back, everybody. Today we're going to finish out Chapter 5, and we're going to be talking about piecewise functions. Last time we talked about radical functions, and now we're going to look at piecewise functions and step functions. Now, piecewise functions are going to be new, not to be confused with our good friend here, Pennywise. Piecewise functions are much nicer than our friend Pennywise here, and a lot more fun to work with. Okay, so a piecewise function is a function that has different rules for different parts of the domain. And if you remember, a domain is your x values. So you can graph it by graphing each part of the function. So if you look at this, this right here is an example of a piecewise function. So it looks a little bit different than the ones that we've seen in the past. So it gives us graph the function f of x. Remember, this is like your y. So y equals, then has two parts. That means we're going to have two parts to this graph. So two different types of graphs here. So the first one is just 2x, but that's only for when x is greater than 0. The second part is this negative x plus 1 for x is less than or equal to 0. Okay, so basically you're graphing two different things. You're graphing y equals 2x, and you're graphing y equals negative x plus 1. Okay, but they're going to have be in different parts of the graph. So this one is for when x is greater than 0. This is for when x is less than or equal to 0. Okay, so if we do this, I'm going to make my graph here first. That's pretty good. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, so the very first thing you want to do when you're graphing piecewise functions is you want to graph the boundary point, okay, so or the points where it is bounded by. So in this case, it's going to be the 0 here. Okay, so to graph the top function, we're going to plug in 0 for your x, because that's what the x is talking about. And this one is just a greater than sign, so it's not equal to. So when we put our first point down, it is going to be an open circle. So if I plug 0 in, I get 2 times 0, which is 0. So my first point is going to be at 0, 0. And that is going to be an open circle right there. Okay, and this is the top one. So now the next thing you have to do is you have to plug in a number that is greater than 0. So I can plug in like 1, say. If I plug in a 1 to your x, 2 times 1, we get 2. So our next point is going to be at 1, 2. So over 1, up 2. And that one can be a closed circle. It doesn't really matter. The only one that matters is your boundary point, the 0. So this one is going to go on forever in the positive direction because x is going to be greater than 0. Okay, but it has to start right there at the 0. So you can't go behind 0. It can't go to the left of 0. Okay, so then we graph the next part, which is this part right here. Okay, and again, you're going to start at your boundary point, so I'm going to plug in 0. So if I plug in 0 here, I get negative 0 plus 1, which is just 1. So my first point for this one is going to be 0, 1. And that one is equal to, right here, so I can put a closed circle at 0, 1. So it looks like this. But now I'm going to plug in points that are less than 0. So for example, if I plug in let's just go with negative 2. Oops. So if I plug in a negative 2, I get negative 2 plus 1. I'm plugging it into this x right here, or this one over here if you want to look at that. Negative 2 is just cancels those negatives and becomes 2 plus 1 is 3. So negative 2 comma 3. So I'm going to graph that point, which is about right here. And that can be a closed circle as well. And then it goes in that direction forever. Since those are both linear, we only need 2 points to graph both parts of that. So notice how I have two parts. I have the red part, which is the bottom here. And I have the green part, which was the top function, this one. Okay, but they're not overlapping, because if they were overlapping, it wouldn't be a function. Okay, so your piecewise functions, they are still functions, meaning they don't overlap, so they all pass the vertical line test, if you remember that. Okay, it only crosses once every time. But it's different rules for different parts of the domain, the x's. Okay, so let's go to the next one. Okay, I'm going to let you go ahead and try this. Now your boundary point has changed. It's now at 2. So remember, you're going to start by graphing that. Okay, so go ahead and try this. Pause it. And 3, 2, 1, pause. Alright, so I plotted my boundary point first. So the green was the top one up here, and then the red was the bottom. Okay, so I plugged in 2 first, and when I plugged in 2 to this x, 2 minus 3 is -1. So my first point right here was 2, -1, and that was an open circle. Yeah, no, a closed circle. That was right here. That was the closed circle because it was equal to. And then I plugged another point that was greater than 2, so I plugged in 3. You can plug any point you want, but I picked 3, and it came out to be 0. So that was my next point right there. And then you just connect your line, and it goes forever in the positive direction. And then on the red one, that was the bottom equation, I plugged in 2. 3 times 2 is 6. 6 minus 2 is 4. So that was my first point. And it was an open circle because it wasn't equal to. Alright, and then I plugged in something that was less than 2, which I plugged in 0 because it was easy. So I got 0, -2, connected those, and that one goes forever in the left direction. So that is your piecewise function. And notice they don't overlap again because at this point right here, even though it hits the red circle and the green circle, the red circle is open, so it's not actually hitting that. So it's not hitting the red circle right here because it's an open circle, but it is hitting the green circle because it's closed. So it is still a function, passes the vertical line test. Voila. Okay. So we talked about absolute value functions earlier this term, and we can also write absolute value functions as a piecewise function. So if you look at this blue box up here, it says you can give a piecewise function definition of the absolute value function, f of x equals absolute value of x, by writing it as f of x equals x for x is greater than or equal to 0, and f of x equals -x for x is less than 0. So basically, you're making the inside of your absolute value positive when x is positive or greater than 0, and then you're just making that negative when x is less than 0. So if you look at this one right here, we have x is less, or x minus 4 on the inside. So that's shifting everything to the right 4, just to review, if you remember. If it's inside, it's a horizontal shift. If it's outside, like +2 right here, that would be a vertical shift. Okay, but if I want to write this as a piecewise function, I'm going to start with my f of x here, equals, and then do this little fun curly brace thing. And the first thing you're going to do is keep the inside the same, so x minus 4. Okay, but that is only going to be for your positive x's, or when x is greater than or equal to 0. Okay, and now on the bottom one, you're going to make you're basically just switching all of your signs on the inside. Okay, so on the bottom it's going to be a -x and a positive +4. Okay, because you're timesing the whole inside by -1, and that's going to be when x is less than 0. So when x is negative, you use the negative of everything. Okay, and that's what gives you the V shape. Okay, because the first one is doing the positive here. The second one is your negative. So that's why you get a V shape, because it's really just a piecewise function that has 2 parts. 1 part, 2 part. Okay, so go ahead and practice this one. See if you can write the piecewise function, and then we'll go over it. And pause this in 3, 2, 1, pause. Okay, so I got f of x equals x plus 3. When I use this semicolon right here, that just means that that's separating the function from the domain. So for x is greater than or equal to 0, -x minus 3, because I switched the inside, when x is less than 0. Now if you notice, I have an equal to on this one, and not on this one. And it actually doesn't matter which one you put the equal on, but you can only have one of them include the equal sign, because otherwise you're going to have an overlapping point, which will not be a function. So you can put it on this one down here, but if I do that, then I have to change this one to just a greater than sign. That way it only accounts for one of those points. Okay. Alright, and lastly, we were talking about step functions, which is a special kind of piecewise function. A step function is a function that pairs every number in an interval, so like an interval of 1 to 2, with one single value. The graph of a step function can look like the steps of the staircase. Each piece is a horizontal segment with any missing points indicated by open circles. Okay, so a school will charter buses so that the student body can attend a football game. Each bus holds a maximum of 60 students. make a graph that models the relationship between the number of students, X, that go to the game by bus and the number of buses that are needed, Y. Okay, so in this case I only need the positive quadrant because I'm not going to have negative students or negative buses. I might have some negative students, but no negative buses. So this is going to be our students down here. This is going to be the amount of buses we need. Okay, so if you think about this, every bus holds a maximum of 60. So they can hold up to 60. So if we want one bus, if we only want to take one bus, that means there is 0, well, I guess not 0 because they're not going to take a bus with 0 students, but 1 to 60 students. If we want 2 buses, that would be a maximum of 120 students. So 61 to 120. 3 buses, we would just add 60 more, so 121 to, what's that, 180. 4 buses, 181 to 240, and then so on. So if we want to graph this, our buses are Y, so I'm going to go up to, 4, it doesn't matter, I guess, 1, 2, 3, 4. My students are going up by 60, so probably want to go by 60s here. Or I guess we can go by, just go by 60s. So that's 60, 120, 180, 240, 300. Okay, now when you make your graph, you're going to want to start, I don't want to start at 1 because I don't have a point for 1, so I'm going to go to 0, but I know I'm not actually going to take 0 students, so I'm going to put an open circle there at 0, at 1, 0, because this is for 1 bus. And I'm taking 1 bus for any amount of students between 1 and 60, so it's going to go all the way over to 60, but as soon as it hits 60, it's going to stop. So I put a closed circle because that is my last, the highest amount of students I can take. As soon as I hit 61, I have to go up to 2 buses. But again, I don't want to go over to 61, so I'm going to put an open circle at 60. So I'm not including the 60, but anything above 60 and less than 120 or equal to 120, I'm going to take 2 buses. And then I'm going to go up at 121 to 180, it's going to be 3 buses. 180 to 240, 4 buses, and so on. So it just looks like this nice little staircase. And notice I have an open circle and a closed circle. That way it is still a function, so it's not overlapping. I don't have 2 points on one x. Okay, so that is what a step function should look like. Basically just looks like a bunch of steps. Okay, and you have a 1 open circle on the left, in this case, and your closed circle on the right. Okay, so go ahead and try this one. This one is basically talking about the same thing, except now you have smaller buses, so it's a maximum of 50 students. So go ahead and try to graph this, and I will do it as well. So pause this in 3, 2, 1, pause. Alright, so this one basically looks the same, except for your stairs are now a little bit shorter. They're not quite as long because you're only going to 50. So between 0 and 50, you're taking 1 bus. 50 and 100, you're taking 2 buses. And so on. And there's just a little bit narrower staircase here, but still works. So that is a step function. Okay, and I think, if I'm right, that is all I have for 5.9. Okay, so that is all of Chapter 5. So that is Piecewise Functions. Hope you guys enjoyed the video. Do the quiz. Make sure you answer the survey. If you think I did a bad job at explaining piecewise functions, then let me know on the survey. If not, well, you just answer whatever you feel like. Okay, I will talk to you crazy cats later. Have a great time, and I'll catch you on the flip side.